Welcome back, everybody. I'd like to start with the second part of this session in which we present the highlights of the 3 Green Cluster projects. And the next project that will be presented is GoGreen. And GoGreen will be represented by Loïc, Bertrand and Silvia Prati. And Loïc Bertrand is a senior researcher at the École Normale Supérieure Paris-Saclay, an associate in the Department of Design and a member of the Chemistry Department. In the Chemistry Department, he leads the research theme on ancient and paleo-inspired materials. He also coordinates the Île-de-France region, its key research and innovation sector on tangible heritage, which brings together 147 no less, laboratories and socio-economic partners, and more than 1,300 scientists. And then Professor Silvia Prati is an associate professor at the Microchemistry and Microscopy Art Diagnostic Laboratory at the University of Bologna. And Silvia's research involves studying manufacturing technique, the state of conservation of an object of cultural heritage, and the identification and development of new restoration procedures. And in addition to GoGreen, she is also a PI in the national project Superstar. The floor is yours.
So good morning. Thank you very much for the presentation. Thank you for asking us to present our consortium. And thanks to the Green Cluster that push the 3 projects to work together since the very beginning. This has been the chance in these 3 years of work to create a lot of synergic activities between us. So my aim is just to present some of the highlights we achieved in GoGreen, a project that is still in progress. It will end at the end of September 2026, involving 15 partners from all over Europe, with the aim of, if I have to pick a word that describe the strategies we discussed from the very beginning, which we brainstorm the structure of this project, is holistic perspective in green conservation. Indeed, what we would like to achieve, and we hope we have achieved in this more than 3 years of project, is an overview that takes into consideration all the aspects in green conservation, from the objects to the operator to the environment, finding the way of proposing more sustainable approaches, where the starting point was the definition of the parameters in order to create a green thinking mind in the community, proposing preventive strategies and decision-making models, going through the development of new methodologies of conservation, considering cleaning and stabilization, which are inspired by historical recipes, biological methodologies, and green chemistry, but also to empower and involve the community in different parts of the project through the production of tools and educational models. So this is the structure of the project. 3 main pillars related to preventive conservation, green cleaning, and stabilization methodologies, supported by transversal workshop about the development of analytical methodologies. This is quite important because if we want to propose methodologies that are more sustainable, we need to have ad hoc methodologies that ascertain whether this methodology are effective for the treatment of the objects. And then there is the task, the work package related to the development of the web app, in order to provide some decision-making tools. All these activities feed the Green Education work package, because our aim of involvement the community is also with the production of educational models that are now ready in order to be used for the future involvement of the community. We were also strongly involved in communication, dissemination activities, organizing workshops, practical demonstration, attending congresses, and all this is managed by our coordinator. Well, another keyword that I want to stress in this highlight presentation is the involvement of the community. This has been achieved in different ways, starting from the constitution of our consortium, where scientists are in strong contact with conservators, and this was a very amazing experience. It is not the first time for me, for sure, but having the possibility to create discussion with the conservators changed a bit my mind in the thinking of all the process. And the involvement of the community is not just inside the consortium, but we try to involve also external institutions in different parts of the project. For instance, the first step in order to define new procedures was the definition of benchmark methodology that have been used throughout the project as comparison with the new procedures. And to do that, we use surveys in order to interview external conservators, which allow us to define what can be considered as a reference for the community. And in our practical demonstration, in where we again involve the external conservators, we use the benchmark defined thanks to their input as comparison for the new materials. So after this few things about the philosophy of the project, I want to present some of the highlights we achieve in the different work package, from preventive conservation, for instance, damage function for different kinds of material were developed, for glass, steel, limestone, ceramics, or paintings, and over 300 objects have been analyzed, and this allowed to define the condition for their storage and the exhibition, which are safe for the work of art, but less impactful for the environment. And we estimated a saving of approximately 3 tons of CO2 per year, thanks to these adaptive measures. We studied methods in order to define early detection of damages in different kinds of materials. And for instance, acoustic emission was proved to be very effective for defining safe conditions for gas storages. As regards green and cleaning methods, our focus was on metals and paintings. So we developed greener complexing agent for tarnish methods, and inspiring from historical recipes, we tested the yeast in order again to propose a bioactive system for tarnished metals, and natural materials such as essential oils and fuller's earth for the cleaning of paintings. In this work package, one innovation that we have produced is the further development of a patent developed by my research group at the University of Bologna, based on the use of materials which are already employed industrially for other applications. They are non-woven materials obtained with a technique called electrospinning, which allow to provide micro-nanoporous, very flexible substrate that can be used also in restoration as a carrier for cleaning agents. And this methodology is more sustainable because thanks to the high superficial area of the medium, you can reduce strongly the amount of solvents or cleaning agent needed to perform the treatment, and also the performance of the system is very good thanks to the good contact between the system and the surface of the object. Moreover, thanks to the peeling off effect that the material exploit, since the system carries the solvent, swallow the coating to be removed and absorb it directly in its microporosity, any mechanical action is eliminated from the surface. So in this extent, this approach is more sustainable because it reduces the amount of solvents needed, but is even more effective and less harmful for the work of art. LCA analysis confirm that using this approach reduces strongly the impact on the environment respect to using cotton swabs. And another advantage of this technology is that you can create a smart material by functionalizing the production of this material. For instance, adding photothermal nanoparticle inside of them, in this case, melanin nanoparticles, so a biomaterial. You can have a photothermal material that can increase locally in a very controlled way the temperature, and this may be quite effective for the removal of high insoluble layer. So in the frame of GoGreen, we further developed this technology, and together with Sati, a factory that is part of the consortium, we started the scalability of this kind of technologies, producing two kinds of material, nanofiber patches combining two different technology, and this allowed to reduce the cost of production, and a self-standing version with this, which is a bit thinner with respect to what can be achieved on lab scale, but very effective and promising. And in collaboration with all the partners involved in the work package of cleaning, we tested this soap for several applications, from the cleaning of paintings to the cleaning of metals, because depending on the cleaning agent, you can use them for different kind of application. As regards the stabilization methods, the focus was on metals and glasses. Huge work has been done on biostabilization, using funging, for instance, to convert copper corrosion product into more stable copper oxalates. This was achieved using different carrier for the fungi, gels, but also the electrospun tissue. Biosorption and ion exchange of chloride in iron were achieved with that biomass. And as regards glass stabilization, a patent has been deposited related to the development of dendritic mesoporous silica nanoparticles, and also a startup has been created in order to commercialize this product. This product is quite innovative and has a wide application, since it can be used to stabilize all glasses objects in order to reduce the degradation processes, but also as an additive for new glass object, since it can be delivered chemicals that provide to the glass specific properties. And now I leave the floor to Loïc.
So, good morning, everybody. The idea behind what I'm going to show now is also transversal, as Silvia Prati has just said. And one aspect that we focused on was the development of support analytical methods within the project itself. And this we were discussing this morning. Oh, sorry, I don't see. Okay. So we were discussing this morning with Vania Virgili from ERIS, and there is also some spirit behind to continue developing analytical techniques that can be further implemented within infrastructural initiative as ERIS. So one aspect that has been developed by IIT was the development of AI-based algorithm to recognize the state of alteration of aged glass. And here we have an example where actually they showed with great success that they could identify the level of crizzling within glass after having trained a model to actually specifically do so. Another aspect which has been a lot of focus during the project was the development of 2D and 3D imaging methods that are particularly suited to the new developments that are currently taking place within GoGreen and I would say beyond, such as looking at the impact of treatments on surfaces, such as here varnish surfaces, where we are mixing modeling of the photoluminescence response with acquisition in simple conditions based on development at Ipanema in order to assess the thickness of remaining varnish during cleaning, and trying that with the green techniques that have been developed particularly by Silvia's group. A side aspect of that, which has taken a lot of momentum from the fundamental aspect, has been the development of methods that are less impactful to study, such as using X-rays or UVs in conditions that normally would be harmful to objects, but decreasing the dose by using computational models in parallel to irradiation. So there is a fundamental aspect to that, which has been published in Science Advances, but we are currently developing a very simple web app actually to implement that with your experiments in various conditions. And finally, for this development, we have both high-end, as Catherine Kuhn is used to saying. So you have an example here where we are using advanced synchrotron techniques to image objects in depth, such as here the surface in 3D, without being invasive of a glass, an historical sample of glass, where you can see here the 3D image, which gives you the speciation of the various compounds, in particularly from silicon and calcium in depth. But we are also developing very practical tools for being employed on the field and trying to connect these photoluminescence developments, for instance, from advanced laboratory setups to far simplified systems that could be used on site to optimize visualization of the cleaning steps, for instance. A second transversal aspect, which also cover, and I will come back to what Silvia was telling about GoGreen being a kind of way of platform to also think about the impact of getting greener all along the value chain and the chain operatoire of analysis, is the development of a series of web apps. I've shown one really about the analytical aspects, but there are three core initiatives within GoGreen. One is a contribution to the development of the REE project, which is led by Lukas Bratash in Krakow. And you probably know that it's a well-known and used platform for preventive conservation that is being developed for many years, but specific modules and dissemination and training activities have been continued within the GoGreen project. A second aspect has been the digital support application from IIT, which really takes into account the various parameters that you would use for a treatment and really look at, in practical terms, what kind of products you will be using, in which conditions, and try to assess what will be the increased gain in using one solution rather than another one, and can help us trying to identify the greenness of the approach which is used. And the third aspect is also a more high-level aspects about taking decisions, and this is developed by our colleagues in Oslo, where they are looking at the various impacts of how do I take decision from the lab and institutional level to the personal level. So we have had, as also Silvia has briefly introduced, a range of education, communication, dissemination and exploitation aspects. I will just focus on a small number of those, and those which we think are quite specific to GoGreen. One of them was involvement in education. So when we thought about, and that was a kind of bet when we were submitting the project to the European Commission, we were wondering, because education for us is also very related to Marie Curie fellowship, so would that part be welcomed within a research project? And we were lucky that this part was actually in, because we are developing educational module directly produced by the consortium. And the rationale behind that is that we realized that it was not only for us about organizing summer school or local training events on some solutions, but actually embedding these aspects directly within teaching institutions, realizing that main institutions such as UVA, such as Bologna, such as our institution, the Courtauld, Oslo, were actually training professionals in conservation and conservation science. So why not directly jump forward and implement that? So one aspect we may think about is how better interconnect research with education within the future project. So this was developed by, so I don't know if it's normal, but Zoom is disconnecting and reconnecting. I hope people can follow. It's not an issue, okay. So we organized that through a series of events and consultation all along the project. So starting very early on drafting these module specification in a meeting in Paris, and then having a series of design and test phases. And we are, of course, at the end of that process, which means that we now have skeletons for teaching modules, and we have beta tested them in our own institutions and in workshops, which I think is quite original in terms of development. A second aspect is the development by Gwen 5 here of, and together with a wide team of these green parameters, and you also have the little leaflet with you. And the idea is to feed these safe and sustainable by design material approaches with parameters that are directly identified within the field. So you know that we have to do this effort for material developments now for each materials that are newly developed, and one way to do that was really to take this aspect directly within the consortium itself, concretely. In terms of output, so I have put here some figures. I'm not coming back to the aspect about the startup development or also the taking up of SATI, of new applications. There has been a lot of conferences. Again, we could have added, I've not put it here, but courses, because we have directly organized courses within academic environment with conservators and with conservation scientists and chemists. But as you can see, there has been a lot of activity. Thank you, Caitlin, for coordinating all this with us. And with that, I would like just to come back to the consortium and to the consortium size. We were, I think, very lucky to be funded and to have this opportunity to cover, again, this chaîne opératoire and value chain from the development of very initial prototypes up to discussing about projects that are products that are and methods that are going to put on the market. And also, again, I think the connections with us as teaching institutions is something that is quite inspiring for the future. Of course, as Silvia said, we could never have done that without many events of involving conservators within our institutions and outside of our institutions. And we truly believe that it is a central component of what we are developing. So thank you very much.